Before today, if you wanted to build a native application for Meta Horizon OS, you had to learn a game engine or roll your own. Unity or Unreal or writing your own thing were your only options. With Meta Horizon OS and Meta Spatial SDK, you can build new spatial applications using the Android frameworks and tooling that you're already familiar with. Sorry, I missed my cue. I'm Carter Earhart. I've been working on Meta Spatial SDK for a long time, and I mostly work on the runtime. Assisting me today is Davis. He'll be up in a bit to talk about immersive media and graphics. Meta Spatial SDK uses tools and frameworks that you're already familiar with so that you can get building quickly. It combines the unique capabilities of Android development with some of the APIs that are available on Meta Horizon OS to build a compelling development experience. Let's take a deeper look into the product tools and resources that are available to you today. It's fast and easy to get started with Meta Spatial SDK. It's a lot like building any other Android app that you've built before. You pull in the Android template sample app and connect your headset, and then you hit the green Go button, and it'll be running on your headset in a couple of seconds. You can check out the immersive activity to get started, but it's super, super simple. The iteration loops are fast, just like they are on mobile. And you can use all of these to immerse yourself in a great experience. You can either create totally new immersive experiences, or you can spatialize your existing 2D Android app. So that means anything that you've already built for Android will work here. We also support hybrid apps, which allow you to switch in and out of 2D panel mode so that if you need a little bit of time to multitask with browser or something, and then switch into an immersive environment, you can. Let's talk about dev workflows for a bit. We know how important developer workflows are to mobile devs, and putting on and taking off the headset can be a little cumbersome. So to help with this, we support, through MetaQuest Developer Hub, both casting and input forwarding. Casting allows you to see what's on your screen so that you can quickly verify any UI change or something that just needs to be taken a quick look at. But input forwarding allows you to drive updates to your scene like you're seeing here. Performance optimization is important for nearly all VR apps. We totally know how difficult it is. And so to do that, we've added all of our existing performance tooling to Meta Spatial SDK. Things like OVR metrics tool, which is a heads-up display that allows you to see FPS, GPU utilization, CPU utilization while you're in your app. We also support RenderDoc, which is our popular frame-by-frame debugging tool. And we support Perfetto, which should feel familiar to a lot of the mobile devs out there. We even have additional metrics that are built into MetaQuest Developer Hub so that Perfetto is even easier and more powerful for Meta Spatial SDK. Coming soon, we're going to also add hot reloading to Meta Spatial SDK. This allows you to update your assets, move things around, and you don't even have to rebuild your app in order to see those represented on the display. This can pair really well with casting in order for you to be able to see instantaneously things like color changes to your background, or you're trying to fit the last brick in your brick wall. As you can tell, we've spent a lot of time making sure that the developer workflows are fast and efficient for mobile devs. But let's talk a little bit about some of the capabilities. I'm going to cover ECS, panels, and mixed reality. And then I'm going to transition to Davis, who's going to cover immersive media and graphics. One of the biggest benefits is that you can leverage existing mobile frameworks and tools that are available to you today. So, for example, we have our panel spatial demonstration that's live on our GitHub. In the panel spatial demo, you have Jetpack Compose panels that are interoperable. So one drives updates to the other, and are facing the user. Meta Spatial SDK is bring your own framework, so you can pick which UI tools and capabilities work best for your app. We support both spawning views and activities into our panels, so if you really need your whole entire app framework for either porting your app or some sort of more comprehensive UI framework, that's available. But if you want something that's lightweight and you can spawn a lot of, you can go with views. On the right, you see the register panel function, which is a new app lifecycle event that we've added to our app system activity. In it, it shows you how quick and easy it is for you to register new panels and spawn them into your scene. In the bottom right is just some layout code that should look familiar to a lot of the Android devs in the room, making it super easy to get started with building the thing that you want. Meta Spatial SDK uses an ECS, which is just like a pattern to divide your data and your functionality. The data model is made up of entities and components, while the functionality is driven by systems. Inside of your entities, you have components, but the entity itself is just a long ID that encapsulates some group of data. Components themselves are a reusable data unit that I think is easiest to understand through examples. These are things like meshes, materials, even transforms. You could add game information. Additionally, our components are made up of attributes, which are something that's fully serializable and usable across the whole data model. Inside of an attribute, you can have things like integers, entities. You could have even some mixed sized data like maps. The S on ECS stands for systems. And systems are an encapsulation that basically is a function that runs once per tick. Inside of systems, it's pretty common to have things like retrieving data from the data model, mutating data either on your Android app or back into the data model, and driving other changes to your app's lifecycle. You may, inside of a system, run a query, get some data from the data model, mutate that data, and set it back to the data model. The ECS can support a wide range of fully featured applications. Things like, you can imagine a scoreboard, which is made up of game info entities. And these game info entities could just have one component in them, which is a game info component. The game info component could be made up of 3 different attributes, like an entity attribute, which is the user who completed the game, a score attribute, which is their score for that run of the game, and maybe a time. Then, when you want to update your 2D panel UI, it's super easy. You can just query for all game info components or entities containing a game info component, and then sort by score, and you're off to updating your view model. Another key element of our data models that I was just talking about are queries, which allow you to correctly get data from your data model. These are super important because each system has to be really performant in order for you to be able to separate your data and your functionality in this way. In this example, we show lookat, which queries for all objects that have to turn and look, and then sets their orientation to face the thing that they're looking at. And it's really just a 2-step process. You can query and then update. Spatial SDK supports panel to 3D, 3D to panel, and 3D and panel to panel communication, as well as component data listeners that help your scene stay always in sync. There's a couple of different ways that you can do this depending on your app's needs. For example, sometimes you want to keep your functionality coupled really tightly with your 2D application. So like maybe you're building a 2D app that's really complicated, but is new to a spatial application. Within this app, you might want to make sure that the code flow is really obvious, that when you're changing something, it updates the immersive environment. So we have different examples that show how you can do this from inside of any 2D activity so that it's easy to follow the code flow. But like alternatively, if you're porting your whole app, this isn't the best solution because you probably want to be able to keep your 2D code and your 3D code separated so that you can use Android's build modes in order to be able to have both of your projects in the same directory. We also support that kind of communication, and in the bottom right, there's an example of it. Spatial SDK comes with many built-in systems and features, such as spatial audio, controllers, hands, locomotions, animations. And these are all really simple tools that make it very easy to get started. One example is transform parenting. Transform parenting is pretty common to all the game devs in the room, but the idea is that sometimes you want the transform of your object to be driven by the transform of another object. So for example, if you've got like a solar system, you want to be able to grab an object like the sun and have the other planets continue to follow you around. Transform parenting is super powerful and can couple well with other built-in functionality to make a lot of things super easy. So for example, if you wanted to make a watch, all that you would have to do is build a cool panel and transform parent it to your wrist. As we mentioned earlier, hybrid app type is supported by Spatial SDK, which allows you to swap in and out of immersive mode for your 2D app. You get all of the benefits of multitasking. You can have browser or anything else that you want, and then you can swap in immersive mode when the time is right. You can imagine an art gallery where you're scrolling through the art exhibit, and then you pick a piece that you want, and it pops open in the full ambiance of an art museum. Or even an educational tool where you're doing some homework, you get a question wrong, and then suddenly it's immersive time, and the teacher's in the front of the room teaching you about the thing that you messed up. It's super easy to get started with Meta Spatial SDK, and I've talked about some of the tools and capabilities that are available to you right now. And now to talk more about graphics and media is Davis.
Thanks, Carter. Now it's time for the fun stuff, you know? I'm Davis Robertson. I'm a graphics engineer on the Meta Spatial SDK team. I want to dive into some of the unique capabilities of the Quest devices and how the Meta Spatial SDK can be used to leverage those for your immersive experiences. Here we have the Meta Spatial SDK, and we support key mixed reality features. You can easily switch from your immersive scene, which is a fully rendered 3D environment, to pass-through, which is a projection of the real world around you for a mixed reality experience. In order to blend your virtual application with the real world, you can utilize the Mixed Reality Utility Kit, which is provided by Meta Spatial SDK. The Mixed Reality Toolkit allows you to have scene understanding of the objects in your area and allows you to create really immersive experiences with it. At the core of MRUK is the scene anchor, which represents an object in the user's environment along with a corresponding semantic classification. The scene anchors allow you to easily find the location and shape of objects in the user's environment and use that as a basis for your virtual content. For example, you can use scene anchors to find the position and location of a user's laptop screen and superimpose a virtual panel on top of it. Or you can use MRUK to find the location of the user's walls and allow users to place virtual art on it to really customize their surroundings. Out of the box, MRUK supports windows, doors, couches, floors, ceilings, all these different things. And you can find more on the Mixed Reality Utility Kit documentation. As you build your spatial experiences, you will want to add 3D graphics to your application. Let's take a look at this object library sample that shows off some of these models. The Meta Spatial SDK supports the GLTF model format, which is an industry standard 3D model format that is often referred to as the JPEG of 3D. GLTF models support a variety of features, including animations, which enable dynamic content driven by keyframes and skeletal rigs. You can also utilize normal maps, which a lot of you in this room are probably familiar with, but you can simulate how light bounces off objects and give an appearance of a more complex model without using complex geometry. You can utilize ambient occlusion to simulate soft shadows in the recesses of your model. All this comes together to make a really immersive experience. And GLTFs can be exported from your favorite 3D modeling programs, or it can be sourced from a variety of locations online. It's really easy to use them in your application. Next, I want to talk about some of the rendering of our GLTF models. The Meta Spatial SDK implements these modern graphics with a physically based rendering pipeline, or PBR. PBR simulates how light bounces off of surfaces and really shows how you can use material properties of these surfaces, such as metallicness and roughness, to have a realistic model in your environment. We also support a feature called ImageBased Lighting, which allows you to capture your environment from all directions of light and use it to plausibly light your model in your scene. I want to emphasize that this makes it easy for developers who may not have experience in game design or graphic design to create engaging content in their apps. It's very easy to create something that looks great. Next, I want to talk about Meta Spatial Editor, which is our spatial composition tool for Meta Spatial SDK. With Meta Spatial Editor, it's really easy for an engineer or designer to import their models and move them around, scale them, rotate them, all within the editor, and have it be a reflection of what is in their app. You can import any of your existing GLTF models into Meta Spatial Editor, or we have a built-in library of objects that range from primitive objects to sample objects that you can use to quickly iterate and build your app. The Meta Spatial Editor exports to a format known as GLTF, which represents a hierarchical composition of these GLTF models and has a little bit of extra Meta Spatial SDK specific metadata, which I'll get into now. The Meta Spatial Editor integrates with all the ECS features that Carter was talking about earlier. You can attach any of our built-in components to your entities in your scene, or use any of your custom components you define in your app. For example, here we are attaching the grabbable component to a panel. The grabbable component is an easy way for you to point at a model and be able to drag it around your scene. Here we are adding it to the panel, and we can have it be reflected in our app without any code needing to be written. One important feature of the Meta Spatial SDK is support for physics out of the box. This makes it an easy way to interact with your virtual environment without having to set up these really complicated physics simulations. In the previous object library sample, we showed how you can drop objects with gravity, forces, and collisions to create an immersive experience. And this is all wrapped in an easy-to-use API that leverages our ECS system. For example, we have this very realistic record shop app. And we can drop records from the sky when a user purchases something in the app. It's a tiny example, but it really shows and gets you thinking of what you can do with these features. And as you saw earlier in the MRUK sample, we were able to shoot basketballs off the walls and furniture of the user's scene. And it can really bring your app together and make it feel like it's part of the environment. Meta Spatial SDK also comes with support for popular immersive media formats. From 180 and 360-degree videos and photos, immersive media is just best viewed in a headset, and Meta Spatial SDK makes it easy for you to display this content to your users. You could check out our spatial video and panorama viewer that's available on the MetaQuest TV app that is actually leveraging the Meta Spatial SDK today. We have also open-sourced a generic media viewer showcase app that you can use to start accelerating your development and start making the next great photo sharing app today. I wanted to take a step back. Carter and I have discussed a lot of awesome features in the Meta Spatial SDK, but I really wanted to focus on two apps in particular, Focus and Geov Voyage, that really show how all these features can come together and make a compelling app. Focus, on the left, is a productivity app for using the Meta Spatial SDK. It utilizes 2D panels and ECS to create these interactive windows. You can see things like text views, images, and web views that all come together to create a unique experience. Next, on the right, is Geov Voyage, which really shows off more of the 3D aspects of Meta Spatial SDK. It utilizes our PBR and image-based lighting pipeline to create an experience that looks like it's in the scene. You can also utilize custom shaders to really hone the look that you would like to achieve. And Meta Spatial SDK is additive to the existing mobile ecosystem and allows you to leverage that to build your experiences. Both of these showcase apps use common AI libraries to enhance the experiences, and also both of them are using common mobile backend infrastructure to stand them up. The bottom line here is it's easy and fast for mobile developers to build experiences with the Meta Spatial SDK because it's using the experience and skill sets that they already know. And we wanted to make sure everybody using the Meta Spatial SDK could get quickly started. That's why Meta Spatial SDK comes with documentation detailing both Meta Spatial SDK specific information as well as spatial and 3D development in general. We also include an API reference that you can use to see what's going on under the hood. And we have many samples that show off all the key features Carter and I were talking about today. My favorite part is we've open sourced these 3 showcase apps to really show how you can use these features, and you can start forking and cloning them and to accelerate your development today. Everything we've covered here today is live and available to developers now. Developers can publish their Meta Spatial SDK apps to the Horizon store today. And publishing an app with Meta Spatial SDK is like publishing any other app to the store. It uses all the same processes and guidelines. You just need to make sure you follow our virtual reality checklist to make sure your app meets our store requirements. Meta Horizon Start is an exclusive program for developers to get started building MR and VR applications today. You might have heard it before, but you can learn from a community of developers, get additional support, and enjoy a lot more benefits. Meta Horizon Start is expanding to include both Android 2D development and apps made with the Meta Spatial SDK. And we're excited and encourage you to try out our new pilot program for mobile developers. All of this is available today, and we're super excited to see what you build. Mobile developers like yourself have built some of the best experiences that people use today. And we recognize the launching of the Meta Spatial SDK as an inflection point where developers can unlock spatial computing to build their next killer apps.